Forged in an era of coal, steel, and relentless innovation, Britain's oldest heavy machines were built to work, not to rest. These giants carved canals, lifted battleships, rolled roads, fed cities, and powered an empire at its peak. While most industrial machines vanished with time, a rare few refused to die. Maintained by skill, tradition, and stubborn engineering brilliance, they still move, lift, haul, and work today. Each machine in this story is more than iron and rivets. It is living proof of British industrial mastery. More than a century later, these mechanical titans continue to run, reminding us that true engineering was built not for convenience, but for eternity. Ruston-Bucyrus, number 95. Steam shovel. Early British steam excavator. The Ruston-Bucyrus, number 95. Steam shovel is a significant example of early British heavy excavation machinery and represents a turning point in the mechanization of large-scale construction work. It was manufactured in Lincoln, England, by Ruston and Hornsby Limited, following a licensing agreement with the Bucyrus Company of Wisconsin, United States, finalized in 1909. This partnership allowed Ruston to produce proven Bucyrus steam shovel designs for use across Britain and the wider British Empire. The number 95 model was built during the 1910s, at a time when industrial growth demanded faster and more efficient earth-moving solutions. The machine was first widely used in railway construction, dock and harbor expansion, canal excavation, and quarry operations throughout the United Kingdom. Before machines like the number 95, these projects depended heavily on manual labor, supported by horses and carts. The introduction of the steam shovel transformed productivity. Operated by a small crew consisting of an engineer, a winchman, and laborers, the number 95 could excavate many tons of earth per day using its steam-powered hoisting and crowding mechanisms. This capability significantly reduced construction timelines and labor costs. During World War I, from 1914 to 1918, Ruston-Bucyrus steam shovels were also employed for military engineering tasks. They were used to construct supply depots, ammunition storage areas, rail connections, and defensive earthworks. Their reliability and ability to work continuously made them valuable assets for wartime infrastructure, both in Britain and in overseas locations where British forces operated. After the war, the Ruston-Bucyrus number 95 continued to serve in civilian roles throughout the 1920s, particularly in road construction, industrial site preparation, and port redevelopment projects. However, by the early 1930s, advances in diesel-powered excavators began to replace steam machinery, as newer designs offered easier operation and reduced maintenance requirements. Despite being technologically obsolete, several Ruston-Bucyrus steam shovels survived due to their robust construction and historical value. Today, preserved examples of the number 95 are maintained in British industrial and transport museums, where they remain operational. These machines are periodically steamed and demonstrated at heritage events, allowing modern audiences to observe early 20th century excavation techniques in action. More than a century after its introduction, the Ruston-Bucyrus number 95 continues to operate as a working symbol of Britain's industrial engineering heritage. Ruston and Hornsby 10RB diesel excavator, early British crawler excavator. The Ruston and Hornsby 10RB diesel excavator is an important milestone in British construction machinery, representing the transition from steam-powered excavation to internal combustion technology. It was designed and built in Lincoln, England, by Ruston and Hornsby Limited, one of Britain's leading engineering firms. The 10RB model was introduced in the early 1930s, following Ruston's extensive experience manufacturing steam shovels under license from Bucyrus and its growing expertise in diesel engines. This excavator reflected Britain's move toward more efficient, self-contained heavy machinery. The first operational use of the Ruston and Hornsby 10RB occurred in civil engineering and construction projects across Britain, particularly in road building, drainage schemes, quarrying, and industrial site preparation. Unlike steam excavators, the 10RB did not require a boiler, water supply, or long warm-up periods. Its diesel engine provided immediate power, making it more flexible and economical for contractors. Mounted on crawler tracks, the machine offered improved mobility and stability on soft or uneven ground, which was a significant advancement over earlier rail-mounted excavators. During the period 1930 to 1939, the 10RB became a familiar sight on major infrastructure projects. British local authorities and private contractors adopted it for urban redevelopment, flood control works, and large-scale excavation tasks. Its robust mechanical design allowed it to operate for long hours with relatively low maintenance compared to steam machines. The excavator was typically operated by a small crew, usually consisting of a driver and a banksman, further reducing labor requirements. With the outbreak of World War II from 1939 to 1945, machines like the Ruston and Hornsby 10RB were repurposed for military and civil defense work. They were used in the construction of airfields, storage depots, defensive positions, and essential wartime infrastructure within Britain. Their diesel engines made them especially valuable during the wartime fuel rationing, as they were more efficient than steam-powered alternatives. After the war, the 10RB continued to operate throughout the late 1940s and 1950s, supporting post-war reconstruction and housing projects. Although more advanced hydraulic excavators eventually replaced cable-operated machines, the 10RB's durability ensured a long working life. Several examples avoided scrapping and were preserved due to their historical significance. Today, surviving Ruston and Hornsby 10RB excavators are maintained by British industrial heritage museums and private preservation groups. Some remain in operational condition and are demonstrated at vintage machinery rallies. These working examples provide a direct link to Britain's early diesel-powered construction era and demonstrate how crawler excavators revolutionized heavy excavation work in the 20th century. Priestman Cub excavator, compact British mechanical excavator. The Priestman Cub excavator is a notable example of early British mechanical excavation equipment, designed to provide compact yet efficient digging capability for small to medium-scale projects. It was developed and manufactured in Kingston upon Hull, England, by William Priestman and Company, a firm established in 1870 that became one of Britain's pioneers in mechanically operated excavators. The Cub model was introduced in the late 1920s to early 1930s, during a period when demand was growing for smaller, more versatile machines that could operate in confined spaces where larger steam shovels were impractical. The Priestman Cub was first used primarily in urban construction, utility trenching, drainage work, and light quarry operations. Unlike large rail-mounted excavators, the Cub was designed to be more mobile and adaptable, making it suitable for municipal projects such as sewer installation, road maintenance, and foundation digging. Its compact size allowed it to work efficiently in city streets, factory yards, and restricted industrial sites where maneuverability was critical. Mechanically, the Priestman Cub employed a cable-operated digging system, a proven design refined by Priestman over decades of excavator development. Power was transmitted through drums, winches, and gears, allowing precise control of the bucket during excavation. Compared to steam-driven predecessors, later Cub variants benefited from simplified operation and reduced setup time, making them economical for contractors who required frequent relocation between job sites. A small crew, often just an operator and a ground worker, was sufficient to run the machine effectively. During the 1930s, the Priestman Cub gained widespread use across Britain, particularly among local councils and private contractors. Its reliability and relatively low operating costs made it attractive during a period of economic constraint, when efficiency and durability were essential. With the onset of World War II from 1939 to 1945, compact excavators like the Cub were employed for civil defense and military support tasks. These included trench digging, air raid shelter construction, utility repairs, and preparation of temporary infrastructure within urban and industrial areas. After the war, the Priestman Cub continued to see service through the late 1940s and 1950s, contributing to post-war reconstruction and housing development. Although hydraulic excavators eventually replaced cable-operated machines, the Cub's robust construction allowed many units to remain operational well beyond their expected service life. Its simplicity made maintenance straightforward, extending its usefulness in smaller contracting firms. Today, surviving Priestman Cub excavators are preserved by British industrial heritage museums and private collectors. Several examples remain operational and are demonstrated at vintage machinery shows and heritage events. These working machines provide valuable insight into Britain's early 20th century mechanical excavation practices and highlight the role of compact excavators in transforming everyday construction work. Cowans Sheldon 30-ton steam crane, heavy British harbor crane. The Cowans Sheldon 30-ton steam crane is a prominent example of British heavy-lifting machinery developed during the height of the country's industrial and maritime expansion. It was designed and manufactured in Carlisle, England by Cowans Sheldon and Company, a firm founded in 1846 that became internationally renowned for its cranes and heavy engineering equipment. The 30-ton steam crane type entered service in the late 19th century, with many examples built during the 1890s and early 1900s, when British ports and dockyards were undergoing rapid modernization. These cranes were first used primarily in harbors, shipyards, and dock facilities, where they handled heavy cargo such as boilers, ship components, railway wagons, and large industrial machinery. A lifting capacity of 30 tons made the crane suitable for demanding maritime tasks that smaller cranes could not manage. Mounted on a robust base, often rail-mounted or fixed to a quay, the crane used steam-powered winches and gearing to provide precise and controlled lifting operations, even in challenging harbor environments. The Cowans Sheldon 30-ton steam crane played a crucial role during the period 1900 to 1914, supporting Britain's global trade network. As the British Empire relied heavily on sea transport, efficient cargo handling was essential. These cranes reduced loading and unloading times and improved safety in busy ports. Their reliability and mechanical strength made them a preferred choice for major ports, including Bristol, Liverpool, and Glasgow, as well as overseas imperial dockyards. During the World War I, from 1914 to 1918, steam cranes of this type were heavily utilized for military logistics. They were used to load artillery, vehicles, ammunition, and supplies onto ships, as well as to support naval dockyard repairs. Their steam power allowed continuous operation without reliance on electrical infrastructure, which was especially valuable during wartime conditions. After the war, the Cowans Sheldon 30-ton steam crane continued in civilian service throughout the 1920s and 1930s, remaining vital to port operations even as newer technologies emerged. Although electric and diesel cranes gradually replaced steam-powered models, many Cowans Sheldon cranes remained in use due to their durability and ease of maintenance. Several examples avoided dismantling and are now preserved at British maritime and industrial heritage sites, including historic harbors. Some remain operational and are still steamed for demonstrations, lifting heavy loads during special events. Today, the Cowans Sheldon 30-ton steam crane stands as a working testament to British engineering excellence and the critical role heavy harbor cranes played in supporting global trade and naval power for more than half a century. Finnieston Crane, Fairfield Titan, iconic Scottish cantilever crane. The Finnieston Crane, officially known as the Fairfield Titan, is one of the most recognizable symbols of Scotland's industrial heritage and a landmark of British heavy engineering. It was designed and constructed in Glasgow, Scotland, by Sir William Arrol and Company, a world-renowned engineering firm, and was completed in 1931. The crane was built for Fairfield Shipbuilding and Engineering Company, one of Britain's leading shipbuilders, to serve the expanding shipyards along the River Clyde. The Fairfield Titan was first used in 1931 to load heavy components such as boilers, engines, gun turrets, and armor plating onto large ocean-going vessels. With a maximum lifting capacity of 150 tons, it was among the most powerful cantilever cranes in Europe at the time of its completion. Its cantilever design allowed it to reach over ships without obstructing dockside operations, making it ideal for the increasingly large warships and passenger liners being built on the Clyde. During the period 1931 to 1939, the Finnieston Crane supported Glasgow's peak shipbuilding years, when the city was known as the Second City of the Empire. Its role became even more critical during World War II from 1939 to 1945, when it was used extensively for military production. The crane lifted heavy naval guns, armored sections, and machinery for warships and merchant vessels essential to Britain's wartime logistics and naval power. After the war, the Finnieston Crane continued operating through the 1950s and 1960s, supporting post-war shipbuilding and industrial repair work. However, as shipbuilding on the River Clyde declined during the 1970s and 1980s, the crane saw reduced use. By 1993, it was taken out of regular service as industrial activity moved away from the area, and the newer lifting technologies replaced traditional dockside cranes. Rather than being dismantled, the Finnieston Crane was recognized for its historical and cultural significance. It was granted Category A listed status, the highest level of protection for historic structures in Scotland. Conservation efforts were undertaken to preserve the crane as an industrial monument rather than a working machine. Today, the Finnieston Crane no longer performs lifting duties, but remains structurally intact and visually dominant on the Glasgow skyline. It is illuminated at night and stands as a permanent reminder of Scotland's shipbuilding legacy. While it is no longer operational, it continues to run in the sense of remaining mechanically complete and maintained. The Fairfield Titan endures as a powerful symbol of British engineering skill and the industrial might that once defined the River Clyde. Fairbairn Steam Crane, Keynsham, historic British rotating crane. The Fairbairn steam crane at Keynsham is a rare and historically significant example of 19th century British lifting machinery, and one of the earliest fully rotating steam cranes still in existence. It was designed by Sir William Fairbairn, a leading British engineer and industrial innovator, and manufactured by William Fairbairn and Sons in Manchester, England. The crane was built in 1875 and installed at Keynsham Dock near Bristol to support the region's growing industrial and maritime trade. The crane was first used in 1875 for dockside cargo handling along the River Avon. Its primary role was lifting heavy goods such as stone blocks, boilers, machinery, and ship components from barges to the quay. At the time, the Fairbairn crane was technologically advanced because of its box girder jib design, which provided exceptional strength while reducing weight. This innovation allowed the crane to rotate smoothly through a full circle, greatly improving efficiency compared to fixed or partially rotating cranes. During the late 19th century, the Fairbairn steam crane became a vital part of Keynsham's industrial infrastructure. From 1875 to 1914, it supported local industries including paper mills, metalworks, and construction suppliers by enabling the rapid movement of heavy materials. Its steam-powered hoisting system allowed consistent operation without reliance on manual labor or animal power, making it a reliable asset for daily dock operations. Throughout World War I, from 1914 to 1918, the crane continued to operate in support of wartime logistics. It was used to handle military supplies, industrial materials, and essential cargo moving through the Bristol area. Unlike electric cranes, its steam power made it independent of vulnerable electrical networks, which was a significant advantage during wartime conditions. The Fairbairn steam crane remained in regular service through the 1920s and 1930s. even as newer crane designs became available. Its robust construction and mechanical simplicity allowed it to outlast many contemporaries. By the mid-20th century, however, changing shipping methods and the decline of small inland docks led to reduced use. Despite this, the crane avoided dismantling due to its solid build and continued usefulness for occasional heavy lifts. By the late 20th century, the crane was recognized as a nationally important industrial artifact. It was preserved at its original location in Keynsham and later restored by heritage engineers to full working order. Today, it is regarded as the oldest operational steam crane in Britain. The Fairbairn steam crane is still steamed and rotated during special heritage demonstrations, allowing the public to witness Victorian engineering in action. Its continued operation more than a century after installation makes it a living example of British industrial innovation and a testament to the durability of early heavy machinery design. Fowler Showman's Road Locomotive President, British Showman traction engine. The Fowler Showman's Road Locomotive President is one of the most famous and best preserved examples of British Showman traction engines built during the golden age of steam-powered fairground transport. It was manufactured in Leeds, England by John Fowler and Company, a leading British engineering firm founded in 1864. The Locomotive President was completed in 1912, specifically for use by British traveling showmen who required powerful, reliable machines to haul heavy fairground rides and equipment across the country. The first use of President was in 1912, when it entered service transporting large amusement rides, generators, and show wagons between fairgrounds. Unlike standard road locomotives used for hauling freight, Showman's engines were specially adapted for entertainment use. President was fitted with a dynamo system to generate electricity, allowing it to power fairground lighting and rides directly. Its decorative canopy, brass fittings, and colorful paintwork reflected the prestige and public-facing role of Showman engines. During the period 1912 to 1939, President traveled extensively across Britain, attending fairs, carnivals, and public exhibitions. These engines played a crucial role in making modern traveling fairs possible, enabling large mechanical rides to operate in towns without permanent electrical infrastructure. The engine's power and reliability made it highly valued among showmen, while its appearance helped attract crowds. During World War I from 1914 to 1918, and later World War II from 1939 to 1945, many Showman's engines were temporarily requisitioned or restricted due to fuel shortages and wartime regulations. However, President survived both conflicts and returned to fairground service after the wars. In the post-war years from 1945 to the early 1950s, it continued working, although steam traction engines were increasingly replaced by diesel-powered lorries and portable generators. By the mid-20th century, most Showman's engines were scrapped, but President avoided this fate due to its condition and historical importance. It was preserved by enthusiasts who recognized its value as a working example of British fairground engineering. Restoration efforts ensured that its mechanical systems, boiler, and decorative elements remained authentic. Today, Fowler Showman's Road Locomotive President is maintained in operational condition and regularly appears at steam rallies, heritage fairs, and historical demonstrations across the United Kingdom. It is still capable of hauling loads and generating electricity, performing the same functions it did more than a century ago. As a result, President stands as a living symbol of Britain's steam-powered entertainment industry and the craftsmanship of early 20th century heavy machinery. Aveling and Porter Road Roller, number 1215, early British road roller. The Aveling and Porter Road Roller, number 1215, is an important example of early British road construction machinery and represents the origins of mechanized road building in the United Kingdom. It was manufactured in Rochester, Kent, England, by Aveling and Porter, a company founded in 1850 by Thomas Aveling. The firm is widely credited with inventing the steam road roller, and number 1215 was built during the late 19th century a period when Britain was rapidly improving its road network to support industrial growth and urban expansion. Road roller. Number 215 was first used for road construction and maintenance, particularly for compacting gravel, stone, and early asphalt surfaces. Before the introduction of steam rollers, road compaction relied on horse-drawn rollers or manual labor, which produced inconsistent results. The steam-powered roller provided steady weight and uniform pressure, significantly improving road durability. Its smooth cylindrical rollers and controlled forward motion allowed operators to create flatter, longer-lasting road surfaces suitable for increasing traffic. During the period 1890 to 1914, Aveling and Porter road rollers became standard equipment for local authorities and private contractors across Britain. Machines like No. 1215 were widely used in towns and cities for paving streets, constructing rural roads, and maintaining major transport routes. Their reliability and mechanical simplicity made them well suited to continuous daily operation. A typical crew consisted of a driver, a steersman, and a fireman, who worked together to maintain steam pressure and control movement. During World War I, from 1914 to 1918, steam road rollers continued operating despite wartime constraints. They were used to maintain essential roads for military transport, supply convoys, and industrial access. Some rollers were also employed on airfield construction and temporary military roads. Their steam power allowed them to function independently of fuel supplies needed by newer internal combustion vehicles, making them valuable during periods of shortage. After the war, road roller No. 1215 remained in service throughout the 1920s and 1930s, even as motor vehicles became more common. Although petrol and diesel rollers gradually entered the market, many steam rollers stayed in use due to their robustness and low operating costs. By the mid-20th century, however, steam rollers were increasingly retired as road construction techniques evolved and faster machinery became standard. Aveling and Porter road roller No. 1215 survived scrapping due to its historical significance and solid construction. It was preserved by enthusiasts who recognized its role in shaping Britain's transport infrastructure. Restoration work returned the machine to operational condition while maintaining original components and appearance. Today, No. 1215 is maintained by British steam preservation groups and is still steamed and driven at heritage rallies and public demonstrations. It continues to compact road surfaces for display purposes, performing the same function it did more than a century ago. As a working artifact, Aveling and Porter Road roller number 1215 stands as a living symbol of British civil engineering innovation and the early development of modern roads. Burrell double crank compound road. Locomotive Britannia. Powerful British road locomotive. The Burrell double crank compound road locomotive Britannia is a prime example of British heavy haulage engineering from the peak era of steam road transport. It was designed and built in Thetford, Norfolk, England, by Charles Burrell and Sons, a company founded in 1770 and internationally respected for its traction engines and road locomotives. Britannia was constructed in the early 20th century, during a period when steam road locomotives were essential for moving heavy industrial loads before the widespread adoption of motor lorries. The locomotive was first used for heavy road haulage, including transporting boilers, industrial machinery, bridge components, and large construction materials. Double-crank compound locomotives like Britannia were designed to deliver exceptional pulling power. The compound system used high-pressure and low-pressure cylinders to improve fuel efficiency, while the double-crank layout provided smoother power delivery and greater torque. This made the locomotive especially suitable for long-distance haulage over Britain's often uneven and poorly surfaced roads. During the period 1900 to 1914, Burrell Road locomotives were widely employed by haulage contractors across Britain. Britannia would have operated as part of a convoy system, often accompanied by a water cart and support crew. These machines played a critical role in supporting industrial expansion by enabling factories, power stations, and municipal projects to receive equipment that railways could not easily deliver directly. A typical operating crew included a driver, steersman, and fireman, all of whom required significant skill and experience. During World War I, from 1914 to 1918, heavy steam road locomotives such as Britannia were used for military logistics within Britain. They hauled artillery pieces, ammunition wagons, and engineering equipment to ports, railheads, and training facilities. Their ability to operate independently of rail infrastructure made them valuable during periods of intense logistical demand. Steam locomotives remained in service throughout the war despite fuel restrictions, as coal was more readily available than liquid fuels. After the war, Britannia continued working through the 1920s, although steam road locomotives faced increasing competition from petrol and diesel lorries. By the 1930s, legislative changes, speed restrictions, and rising maintenance costs led to the gradual decline of steam haulage on public roads. Many locomotives were scrapped during this period, but Britannia survived due to its condition and historical value. The locomotive was later preserved by steam enthusiasts who recognized its importance as a representative example of British road locomotive design. Restoration work focused on maintaining original mechanical components, including the compound cylinders, gearing, and boiler. Today, Burrell Britannia is maintained in operational condition and regularly appears at steam rallies and heritage transport events in the United Kingdom. It is still capable of hauling heavy loads, demonstrating the immense power and engineering sophistication of early 20th century British road locomotives. As a working machine, Britannia stands as a testament to Britain's steam haulage heritage and the engineering skill of Charles Burrell and Sons. Foden C-Type steam wagon, early British steam truck. The Foden C-Type steam wagon is a significant example of early British commercial road transport and represents the transition from horse-drawn haulage to mechanized freight movement. It was designed and manufactured in Sandbach, Cheshire, England, by Foden's Limited, a company founded by Edwin Foden in 1856. The C-Type steam wagon was introduced in 1908, at a time when British industry required reliable road vehicles capable of carrying heavy loads over long distances without dependence on railways. The C-Type was first used for commercial freight transport, including the movement of coal, building materials, brewery products, agricultural goods, and industrial machinery. Unlike earlier steam wagons, which were often complex and costly to operate, the Foden C-Type was designed to be robust, relatively simple, and economical. It used a compact steam power system integrated into a rigid chassis, making it suitable for everyday commercial use rather than specialist haulage only. During the period 1908 to 1914, the Foden C-Type became one of the most widely adopted steam wagons in Britain. Local authorities, private haulage firms, and industrial companies valued its reliability and load-carrying capacity. The wagon typically operated with a crew of two, a driver and a steersman or mate, who were responsible for firing the boiler, steering, and handling cargo. Its ability to haul loads of several tons made it a practical alternative to both horse teams and early petrol lorries. During World War I, from 1914 to 1918, Foden steam wagons were extensively used for military logistics within Britain. They transported supplies, ammunition, construction materials, and equipment between factories, ports, railheads, and military depots. Steam wagons were especially valuable during wartime because they ran on coal or coke, fuels that were more readily available than petrol. This ensured continued operation despite fuel shortages and rationing. After the war, the Foden C-Type continued to serve throughout the 1920s, supporting Britain's post-war economic recovery. However, by the 1930s, advances in petrol and diesel engine technology began to reduce the competitiveness of steam wagons. Internal combustion trucks offered higher speeds, easier operation, and lower staffing requirements. As a result, many steam wagons were withdrawn from service, and scrapped during this period. Despite this decline, several Foden C-Type wagons survived due to their durable construction and historical importance. Preservation efforts by enthusiasts and collectors ensured that representative examples were restored rather than dismantled. Restoration work focused on maintaining original boilers, running gear, and bodywork to preserve historical accuracy. Today, surviving Foden C-Type steam wagons are maintained in operational condition by British steam preservation societies and private owners. They are regularly demonstrated at steam rallies, transport museums, and heritage events, where they still haul loads and drive on public roads under special permissions. As working machines, Foden C-Type wagons provide a direct link to the early era of British motor transport and illustrate how steam technology helped shape modern commercial road haulage. Sentinel DG4, steam wagon, British high-pressure steam wagon. The Sentinel DG4 steam wagon is an important example of advanced British steam road transport and represents the final stage of steam wagon development before diesel vehicles became dominant. It was designed and manufactured in Shrewsbury, England, by Sentinel Wagon Works, a company formed in 1906 as a subsidiary of Alley and McClellan. The DG4 model was introduced in the late 1920s, when Sentinel focused on high-pressure steam technology to improve efficiency, reliability, and operating costs. The DG4 was first used for commercial freight haulage, including the transport of coal, building materials, food products, and industrial goods. Unlike earlier steam wagons, Sentinel designs used high-pressure, superheated steam generated in compact vertical water tube boilers. This system allowed faster steam raising, reduced fuel consumption, and lower water usage. The enclosed engine and boiler arrangement also improved safety and cleanliness, making the DG4 more practical for everyday commercial operations. During the period 1928 to 1939, Sentinel DG4 steam wagons were widely used by British haulage firms, municipal authorities, and industrial companies. They were particularly popular with operators who valued fuel flexibility, as the wagons could run on coal, coke, or other solid fuels. A typical crew consisted of a driver and a mate, although some experienced operators ran the vehicle single-handed. The DG4's strong chassis and smooth power delivery made it suitable for long-distance road haulage as well as urban deliveries. During World War II, from 1939 to 1945, Sentinel steam wagons played a crucial role in Britain's wartime transport system. With petrol and diesel heavily rationed, steam wagons became strategically important. DG4 wagons were used to move supplies, raw materials, and equipment between factories, rail depots, and military installations. Their ability to operate independently of liquid fuel supplies ensured continuity of transport during critical periods of the war. After the war, the DG4 continued operating throughout the late 1940s, supporting post-war reconstruction and industrial recovery. However, by the 1950s, improvements in diesel engine technology and changes in transport legislation made steam wagons increasingly uneconomical. Many were withdrawn from service and scrapped as operators transitioned to faster, lighter, and less labor-intensive diesel trucks. Despite this decline, several Sentinel DG4 wagons survived due to their solid construction and historical significance. Preservation groups and private owners recognized their importance as the most technically advanced British steam wagons ever built. Restoration efforts focused on maintaining original high-pressure boiler systems, engines, and bodywork while ensuring safe operation under modern regulations. Today, preserved Sentinel DG4 steam wagons remain in operational condition and are demonstrated at steam rallies, transport museums, and heritage road runs across the United Kingdom. They are still driven on public roads under special permissions, hauling loads and showcasing their distinctive high-pressure steam technology. As working machines, Sentinel DG4 wagons represent the peak of British steam road vehicle engineering and stand as enduring symbols of innovation at the close of the steam transport era. Ruston Proctor Road, Roller, number 1239. British steam road roller. The Ruston Proctor, road roller. Number 1239 is a representative example of early British steam-powered road construction machinery and reflects the rapid mechanization of public works in the late 19th and early 20th centuries. It was manufactured in Lincoln, England by Ruston Proctor Company, a firm established in 1857 that became one of Britain's major producers of agricultural, industrial, and civil engineering machinery. Road roller. Number 1239 was built in the early 1900s, during a period when local authorities increasingly relied on steam rollers to improve road quality and durability. The roller was first used for road construction and maintenance, particularly for compacting stone, gravel, and early tar-bound surfaces. Before steam rollers became widespread, road compaction depended on horse-drawn rollers and manual labor, which produced uneven and short-lived results. Machines like number 1239 provided consistent weight, controlled movement, and reliable compaction, resulting in smoother and longer-lasting roads capable of supporting heavier traffic. Its wide front roller and driven rear rollers allowed even pressure distribution across road surfaces. During the period 1900 to 1914, Ruston Proctor steamrollers were widely adopted by municipal councils, highway boards, and private contractors throughout Britain. They were commonly used in urban street paving, rural road building, and maintenance of major transport routes. A typical operating crew consisted of a driver, a steersman, and a fireman, each responsible for controlling direction, speed, and boiler operation. The roller's mechanical simplicity and robust construction allowed it to operate daily with minimal downtime. During World War I, from 1914 to 1918, steam road rollers like number 1239 remained in essential service. They were used to maintain roads required for military transport, industrial supply routes, and access to ports and rail depots. Some steamrollers were also employed in the construction of temporary military roads, storage yards, and early airfields. Their reliance on coal rather than liquid fuels made them particularly valuable during the wartime shortages. After the war, road roller number 1239 continued working throughout the 1920s, even as motor traffic increased significantly. Steamrollers remained competitive due to their durability and low fuel costs. However, by the 1930s, petrol and diesel-powered rollers began to replace steam machines, offering higher speeds and reduced crew requirements. As a result, many steamrollers were withdrawn from service and scrapped. Ruston Proctor Road, roller number 1239 survived this decline due to its solid construction and historical importance. It was preserved by steam enthusiasts who recognized its value as an example of British municipal engineering. Restoration efforts focused on maintaining original components, including the boiler, rollers, gearing, and controls. Today, number 1239 is maintained in operational condition by British steam preservation groups. It is regularly steamed and driven at heritage rallies and public demonstrations, where it continues to compact surfaces for display purposes. As a working machine more than a century old, Ruston Proctor Road roller number 1239 stands as a living reminder of Britain's steam-powered road building era and the engineering skill that shaped modern transport infrastructure. Marshall Sons and Company Agricultural Traction Machine, number 42173. British Agricultural Traction Machine, the Marshall Sons and Company. Agricultural Traction Machine, number 42173 is a classic example of British steam-powered agricultural machinery and reflects the mechanization of farming during the late 19th and early 20th centuries. It was designed and manufactured in Gainsborough, Lincolnshire, England by Marshall Sons and Company, a firm founded in 1848 that became one of Britain's most respected builders of steam traction engines. Machine number 42173 was produced in the early 20th century. a period when steam power was transforming agriculture across Britain and the wider British Empire. The traction machine was first used primarily for agricultural work, including plowing, threshing, hauling loads, and driving stationary equipment via belt drive. Before the widespread use of tractors, steam traction engines like No. 42173 provided the power needed to work large fields efficiently. Using cable plowing systems, the machine could pull heavy plows across farmland that was previously difficult to cultivate with horse teams alone. Its ability to deliver sustained power made it a vital asset on large farms and estates. During the period 1900 to 1914, Marshall traction engines were widely adopted by British farmers, contractors, and estate owners. They were commonly used during harvest seasons to power threshing machines and sawmills, as well as to haul wagons loaded with grain, hay, and equipment. A typical operating crew consisted of a driver, a steersman, and a fireman, all of whom required technical skill to manage boiler pressure, steering, and safe operation. The machine's robust construction allowed it to work long hours under demanding conditions. During World War I, from 1914 to 1918, agricultural traction engines became strategically important. With many farm workers serving in the armed forces, steam engines like No. 42173 helped maintain food production. They were also used for hauling military supplies, timber extraction, and road transport in rural areas. Their reliance on coal rather than liquid fuel made them especially valuable during wartime shortages. After the war, No. 42173 continued operating throughout the 1920s, supporting agricultural production during a period of economic adjustment. However, by the 1930s, internal combustion tractors began to replace steam traction engines. Petrol and diesel tractors were easier to operate, required smaller crews, and were more suitable for smaller farms. As a result, many steam traction machines were retired and scrapped. Marshall Sons and Company Agricultural Traction Machine, No. 42173, survived this decline due to its solid construction and historical value. It was preserved by steam enthusiasts who recognized its importance as a representative example of British agricultural engineering. Restoration work focused on maintaining original mechanical components, including the boiler, gearing, and drive systems. Today, No. 42173 is maintained in operational condition by British steam preservation groups. It is regularly demonstrated at agricultural shows, steam rallies, and heritage events, where it still plows fields and hauls loads. As a working machine more than a century old, it stands as a living reminder of how steam power transformed British farming and rural industry. Armstrong Whitworth Hydraulic Crane, British Industrial Hydraulic Crane. The Armstrong Whitworth hydraulic crane is a landmark example of British industrial lifting technology and represents the early adoption of hydraulic power in heavy engineering. It was developed and manufactured in Newcastle upon Tyne, England, by Sir W. G. Armstrong and Company, later known as Armstrong Whitworth, a firm founded in 1847 by engineer and industrialist William George Armstrong. Armstrong was a pioneer of hydraulic engineering, and his company became world famous for cranes, armaments, and heavy industrial machinery. Hydraulic cranes of this type were first introduced during the mid-19th century, with widespread use expanding in the 1870s and 1880s. The Armstrong Whitworth hydraulic crane was first used in dockyards, shipyards, rail yards, and heavy industrial sites where precise control and reliable lifting were essential. Unlike steam cranes, these machines used pressurized water supplied through hydraulic mains, a system pioneered by Armstrong. This allowed smooth, powerful lifting and rotation without the need for onboard boilers. The crane could lift heavy loads such as ship components, artillery pieces, locomotives, and industrial machinery with exceptional accuracy, making it ideal for crowded industrial environments. During the period 1870 to 1914, Armstrong hydraulic cranes became standard equipment in major British ports and industrial centers, including Newcastle, Liverpool, London, and Glasgow. Many were installed permanently on quaysides or inside factories, where they operated continuously as part of centralized hydraulic power networks. Their reliability and ease of operation reduced labor demands and increased productivity, contributing directly to Britain's dominance in global trade and shipbuilding during the late Victorian and Edwardian eras. During World War I, from 1914 to 1918, Armstrong Whitworth hydraulic cranes played a vital role in military production and logistics. They were used to lift heavy guns, naval components, ammunition, and armored materials in dockyards and factories. Because hydraulic cranes relied on centralized water pressure rather than fuel supplies, they remained highly effective during wartime shortages. Their continued operation supported naval construction and arms manufacturing throughout the conflict. After the war, these cranes continued operating through the 1920s and 1930s, even as electric cranes became more common. Many Armstrong hydraulic cranes remained in daily use because of their durability and low operating costs. By the mid-20th century, however, changes in industrial infrastructure and the decline of hydraulic power networks led to their gradual retirement. Several Armstrong Whitworth hydraulic cranes survived dismantling due to their robust construction and historical importance. Many were preserved in situ at former dockyards or transferred to industrial heritage museums. Restoration efforts focused on maintaining original hydraulic systems, gearing, and structural components. Today, preserved Armstrong Whitworth hydraulic cranes can still be seen in working or near working condition at heritage sites. Some are occasionally operated using restored hydraulic systems for demonstrations. As enduring industrial monuments, they stand as powerful symbols of British engineering innovation and the origins of modern heavy lifting technology.